5 is going to do for us is it's going to give us the opportunity to see when we start using factoring to cancel and reduce polynomials. This is kind of our intro. So we're going to do some old school long division, except it's not just with numbers like when you're in 4th grade. So you're like, well, I mean, remember again, it's like, okay, 3, no, not into 1, 3 into 14, okay. You guys are like, really? You're really gonna, 3 goes into 22 7 times. And you're kind of working along going, seriously, Hardy, this is algebra 2. What remains 1? What does this have to do? Or, I could even say, since I got 1 left and I'm here, it could be like 47 1/3. Okay, if I really wanted to get fancy. This, if you know this basic skill, okay, if it hasn't been too long since you've dealt with these things, polynomial long division is not really a big deal at all. Because all we're going to do is the exact same thing, except now, instead of just a number, okay, in this case I have a binomial term, and I'm going to divide it into my trinomial here. Here's how this works. When I go to do the division on this, I'm going to divide my first term under the division symbol by the first term here. So in other words, my first step is going to be to take x squared divided by x. So what would that be? Okay, that'd just be x. Again, I'm just subtracting the exponent. 2 minus 1 is 1. So that x goes up here. Like, all right, so then what? The next step, and this is just a 2-step process that we just keep continuing to the end, I'm going to take that x, and I'm going to multiply it by my divisor. So, of course, I've got to distribute that through x squared minus 3x. That goes underneath, sort of like went up above. I did 3 times 4 is 12, and then I subtracted it. I'm going to do the same thing here. So when I do that, x squared minus x squared, okay, that goes away. Be careful with your signs, though. Negative 5x minus a negative 3, what happens when I minus a negative? Okay, it becomes plus. So this is really negative 5 plus 3. And then any terms I have left get brought down. So the 6 is going to be brought down. So this is kind of a recap here of the first part, so we're not quite done yet. First term divided by first term. Okay, whatever I get goes up top, like I'm doing long division. And then that value gets multiplied by my divisor. And that's what I put underneath and subtract. Again, just like long division, just has a few variables involved. So then, I do the process over again. So now, this is what I have underneath. So I take that term, and I divide it by the first term in the divisor. And whatever I get, what goes up here. And then just like I did the first time through, I take that negative 2, multiply it by my divisor. Again, remembering to distribute to both terms, not just the first one. And then that value goes underneath, and I subtract. Now this time, kind of cool. Negative 2 minus negative 2, that wipes them out. 6 minus 6 wipes them out and gives me 0. That is my answer. If I divide x squared minus 5x plus 6, and I divide it by x divided by 3, that's my answer. Well, now, here's where I'm talking about where it's a little bit of an introductory thing. Because let me show you what we're actually going to work towards in the future. Now this won't work on every one of these, so I don't want some of you to get a bright idea. Ooh, here's a shortcut. What we're working towards getting to, there will be a point where this same exact problem you'll look at, and it'll look like this. And I'll say, okay, can you factor anything? You'll be like, yeah, I can factor what's up here. Well, what multiplies to positive 6, but adds to negative 5? Negative 3 and negative 2. What's alike? Okay. That's what we're working toward. The time when we're going to be able to do all of this factoring and all of this fancy stuff to be able to get the same answer. But again, this one came out nice. You're going to find out soon they don't all come out nice, which is why we don't just go straight to this right now. This is something we'll get to, just not quite yet. Okay? But again, you're going to get to a point where you're not going to need to show all this either. I just do this on the first one so you can kind of get used to the pattern a little bit. Because this next one, we're going to try just kind of on the fly here. But if there's something that I do that seems kind of odd or strange or you don't get, let me know right away because I want to try and get it fixed up. All right, here we go. First term divided by first term. X squared divided by x is x. So now, take that x, multiply it times both terms of your divisor. Whoops, get that back here. So x times x is x squared. X times 1 is 1x. And I'm going to subtract that. Okay, just like long division. My first terms will always cancel out then. 6x minus x is 5x. And I just bring any other terms that are left over down. And I start the process over again. It's only 2 steps. 5x divided by x. What do I get? 5. And I always know if I've done it right by when I go to multiply. 5 times x is 5x. 5 times 1 is 5. And those first terms, if I've done it right, are always going to cancel. That's never going to change. So those wipe out. 2 minus 5 is negative 3. Now, this is where it's a little different. Old school division, I just write r negative 3 and be done. But that's not how this works. This, if you have a remainder left over, here's how it goes. We're going to add this remainder in whatever it's going to be. So in this case, it's negative 3. And you put it over whatever you were dividing by. So your remainder is just going to be whatever this last value is divided by your divisor. There's going to be a fraction on the end. It doesn't come out clean. And that's why what I showed you in number 1 wouldn't work for number 2. Because I can't factor this. So I end up with kind of an ugly looking remainder on that. But it's just kind of an introduction again thing. Now again, it can get a little bit into the larger realm here. For right now, I'm going to jump down to 4. Because I want to hit you up with another one of these that kind of throws a twist in. So kind of keep those first 2 in mind. You're like, okay, x plus 2, x third. Make sure you copy carefully, because if I change an exponent or something, that's going to mess me all up. All right, here we go. First term into first term. So 3x to the third divided by x. 3x squared. If I did 3x squared times x, and 3x to the third, and 3x squared times 2 6x squared. I'm going to subtract that from what I got. First terms cancel. That's a good sign. 2 minus 6 is negative 4x squared. And those last two terms that I haven't done anything with just get brought down. Their signs stay the same. I'm not subtracting those. Just those first two. The process starts over. First term divided by first term of my divisor. So what's negative 4x squared divided by x? Negative 4x. I just lose one from my exponent. Notice my degree has gone down from 2 to 1. Okay, that's another kind of hint. So I'm going to distribute this through. Negative 4x times x. Negative 4x squared. Negative 4 times 2 is negative 8x. Then I'm going to subtract that, and I'm going to run out of room. I'm writing too big. Again, negative 4 minus negative 4 cancels. This minus negative 8 will become plus. So x plus 8x is 9x minus 4. So I just keep bringing that 4 down. I haven't used it yet. One more time. Dang, glad these aren't like 5 terms long. 9x divided by x. 9. Last time. 9 times x is 9x. 9 times 2 is 18. Subtract it. The x's cancel. Woohoo. Negative 4 minus 18 is negative 22. Well, I can't do anything with x, so that's what's left. So again, my remainder is negative 22 over my divisor, what I've been dividing by. So sometimes they'll come out nice, sometimes they won't. If they don't, you just kind of tuck it on the end with my divisor, and I'm set. You're like, whew, that's kind of long, huh? Wouldn't it be awesome if there was a shorter way of doing this? Oh, wait, there is. Okay. Now, unfortunately, no. That would be nice, but no. Synthetic division, and again, you've got to keep the terminology on this right, because a couple of times I'll be asking you to do long division. Okay? Synthetic division is kind of our shortcut way of doing the same thing. You'll understand why I'm drawing this arrow in a minute, when we actually get doing one of these. Okay, when I go to do synthetic division, you're like, okay, this looks a lot like what we were just doing. So how is this going to be great, new, and different? One thing you need to be aware of is we're going to switch the sign of the divisor. And I'm going to be real specific with that here in a minute when we get into the two examples. Yep, we can pop back up. We'll pop back up in a minute if we need to. Just trying to hit a little of everything right now, and then we'll go back and hit things again. So for instance, here, this one's going to become 3 that I divide by. This one's going to become negative 6. So whatever sign is in my divisor, if it's a minus, it's going to become plus. The plus is going to become minus. Because then what I do is I say, okay, I'm going to take just the coefficients. I'm going to lose my variable. So like, I don't see a number in front of x cubed, so that's a 1. I have a negative 2, a negative 10. 3 is going to get in my way. 10 and negative 15. It's getting blasted out by my 3. When you do synthetic division, we're actually doing the same thing we do in long division, except it goes faster. So here's how it works. My first term just gets dropped down to the bottom. Every time. Never will be different. Well, once you see a couple, I think you're going to see that it's going to go easier. Drop it down, multiply these together. 1 times 3 is 3. Add down, which is 1. Multiply your answer times what's in the box. Add down. Multiply your answer times what's in the box. Add down. You're like, okay, there's still no variables, and there's a whole bunch of numbers. So now what? Okay, the variables come back in with one thing to pay attention to. What's the largest variable you see in the original problem? That's Q. Okay, we go down 1 degree. So x squared, then x. Then I don't have a variable anymore because I've gone from 2 to 1 to 0. That means that's the remainder, which means we just put the x minus 3 over it. I can put the plus in there still if I want to, but if I don't, it's not going to be incorrect. Okay. So once you get the hang of the 2 steps, typically this is going to be easier. Now some of you may find the other way a little more. It's longer, but more, it's like everything kind of sets up better for you. So here, let's try this again here. So I got a 1 here, and a -1, and a -42. The process works the same way. Drop the first term down, whatever it is. Now it just becomes the multiply and add game. Multiply these together, add down. Multiply these together, add down. And then we run the process the same way. Look at your largest degree, your largest exponent in the original problem, and lose 1. So it's just x, which means my next term's done, and I have no remainder this time. It's just x minus 7. I'm done. Okay? Any issues before I throw the twist in? Oh! Always have to throw the twist in. Okay. So back we go. Twist time. Alright, number 7. What number's going in the box? -2. Now comes the issue. You'll notice on numbers 5 and 6 that we did on the front, it goes right down in degree order. So like the first one we went 3, 2, 1, regular term. Let's flip back over here. So you'll notice 3, 2, 1, nothing. 2, 1, nothing. It goes step by step. Well, what happens if we start trying to skip steps? Ooh, it goes from x to the 3rd down to a constant. You have to put zeros in. So here's how this works. This, x to the 3rd minus 8, as far as we're concerned with this, is x to the 3rd plus 0x squared plus 0x minus 8. If there are missing portions in your steps, you have to put a 0 in. Otherwise, this gets all messed up. So when I go to fill this in, my coefficient there is 1. My squared is 0. My x term is 0. And then my constant term comes in. If you lose a 0, it will not work. I started with x to the 3rd. But I have to go down step by step. So x squared has to come next, but I don't have one. So I use a 0 to fill in. Then x has to come, but I don't have one. So I throw a 0 in. And then the minus 8 comes at the end. Then everything's normal. Pull that first term down. 1 times -2 is -2. Add it down. Negative times negative is positive. Add down. And -8 will give me -16. Now, all we have left to do is put some variable terms in. What am I going to start with? X squared. Because I started with x cubed in the problem, we always start one less on the degree. So x squared minus 2x plus 4. Oops, I've run out of x's to use. That's my remainder. And again, if you want to put the plus in here with that, you can. But if you don't, it's not going to be wrong. You're like, okay, maybe. One more, we'll see if we've caught on here. What's going in the box? -2. All right, we got that down. What's going in here to the right? So I've got x cubed, I've got x squared. I have to make sure there's a 0x in there. I've got to hold the place. If I can remember that one little thing, that's going to make this easier. First number gets pulled down, then start the multiply and add game. Multiply and add. Multiply and add. Multiply and add. All right. What's this bad boy look like in final form? Oh, you're rolling. Then everybody stops. Perfect. So that's always going to be an option for us. Okay. So again, this is synthetic division, different from long division, where we actually keep the variables in the whole time. So then this last part is going along the same way. But you're like, oh, here comes one little twist again. All right, so f of x, here this is. If x equals -2, it's one of the polynomial's zeros. In other words, what they mean by that is, if I were to punch this in the graphing calculator, what would happen is, one of the answers, one of the places that my graph would cross the x-axis would be at -2. So there actually is a way that the calculator can help us to figure out how this is going to work. So here is the very funky looking graph that you get when you put that in your calculator. Notice x is -2. There's one of the places that it crosses the x-axis. That's one of my solutions. So you're like, wait a minute. So is there a way, if you were asked to find all the zeros, that you would do it with the calculator? Huh? Looks like table would be an easy way to go. Any place that I see a 0 for y, oh, 3 would be an answer, 4 would be an answer. And we already knew -2 was an answer. So if you were asked to find the zeros, that's kind of nice. You know, make this work out. But for now, because again, we're kind of building on things, what you need to keep in mind is this value, when I go to do synthetic division, don't switch the sign if they tell you what a 0 is. Because you're not being given the binomial term like you were up here where I have to change the sign. Here I'm literally giving you the number. So when I go to build this, if they tell me a 0, I just plug that in the box. Everything else is the same. I'm still going to watch, okay, 3, 2, 1, none. Okay, don't need zeros this time. That's good. So now, I can go ahead and do my business. Drop the first one down. Multiply. Add down. Multiply. Watch your sign. Add down. Multiply. Add down. Sweet. No remainder. Okay. So what's my final answer going to look like? Plus 12. And you know what the cool thing is? We just looked and saw those other zeros were going to be 3 and 4. Guess what? Just on a fun side note, what would happen if I took this and I factored it? You're getting a little intro into what's coming. Multiplies to 12 adds to negative 7. Oh, negative 4 and negative 3. Huh. X equals 4, x equals 3. I've got all my zeros by factoring. Okay? Calculator's cool. Being able to factor also, another tool in the toolbox, is even better. We're becoming multifaceted here. But this is where the stuff all goes together and why the factoring is important. Why you need to be able to understand how it works. One more just to be sure. All right, 10. What goes in the box? 10. Okay. Any holes to work with? No. 1, 12, 12. Is there any zeros? So like up in number 7 and number 8 where I had a mystery spot that wasn't there. So now we don't have any this time. We can just do our thing. Drop that 1 down. And again, multiply and add. Multiply and add. Multiply and add. And again, I started with a degree of 3, dropped down 1 degree, x squared, x, so change. So that's kind of what we're doing. Now again, if you were asked at this point to factor this, I could. What multiplies to negative 8 and adds to negative 2? And that's how this would end up working. You can factor that part out to get to your solution. X would equal 4 and x would equal 2. Heck, let's make sure. See, this is one thing. This is where having a calculator can be useful. Not to just give me, what the solution is. I mean, that's always nice, but can't even see parts because 80 is kind of a big number. But I notice there's an answer at negative 2. There's an answer at positive 4. And if I wanted to get that last set of parentheses in, that last value, I see it crosses down here at 10 too. So actually, the complete factorized form of this would be this. The only one that we would, negative 10. Negative 10. Oh, that was almost bad. Okay? So it's kind of neat to see how these things go together. I wouldn't want to have to factor that normally, shoot. But we're learning about the zeros. We're starting to grow with that. All right. Other issues. Do we want to do 11? Do we want to go back and hit 3? Or do you want me to just get out of the way? You're fortunate because you'll have to borrow it off the institute desk when she gets here. That's not today, I guess. So